Hello, you're welcome to the physics series with Excellence Simplified. And today I'm going to be taking you through past questions, JAMB and WAEC past questions on this hot topic. Now, one thing you should know is that fundamental and derived quantities is a topic that you cannot escape in JAMB and WAEC. You must see it. In fact, if you don't see it, just know that what you are writing is not physics. Maybe it's literature. All right, so I'm going to be using past questions from different years to demystify this topic. Let's get started. All right, now the first question here says the dimension of electromotive force are dash. So the dimension. Now the first thing, once you are asked to find dimension, the first thing you are to do is, what is the formula? Now we're asked to find the dimension of electromotive force. So the first thing is to write the formula. Now, first thing, electromotive force, I'll use EMF. So if you see EMF represents electromotive force. Now, electromotive force, the formula is work done per unit charge. That's electromotive force. Work done per unit charge. So now we are going to look at work and charge. So you agree with me that work done is force times distance, right? That's work. Then all over charge. The charge is current times time. So we are breaking it down gradually. Now let's continue. From here, force is same thing as mass times acceleration. This one is for force. Then times distance, this distance here. Now all over current times time. All right, now if we move on, you see that mass, let's leave the mass there. Mass is a fundamental quantity. Let's leave it as it is. Times acceleration. Now, acceleration, let me bring it here. Acceleration is same thing as change in velocity all over time. Change in velocity over time, that's acceleration. And velocity is distance over time. So distance over time. Changing as displacement over time, but to use it interchangeably sometimes. But the right thing is displacement over time, then t here. All right, so now this will be distance over time. You know, this is same thing as writing it as distance over time, then times 1 over t. Remember, this is same thing as distance over time divided by time. But rule of mathematics, if I want to change this division to times, I'll take the reciprocal, the inverse. So that will be s over t square. S over t square. That is acceleration. So this same acceleration is now distance. You know, distance here is length, right? So distance is length, L, all over time here. Time is a fundamental quantity, so I'll leave it as t. Now when you're writing dimension, use capital letter, but we have square with it, so t square. Now if you look at this is the dimension for acceleration, and if you don't want to write it like that, you can write it as lt raised to the power minus 2. So this is same thing as this. So this one, everything we solved here now was just for acceleration. So I'm bringing acceleration in now as, now let me make this capital letter since it's dimension we are talking about now. So this will be capital letter N, then times our acceleration. Now we've solved acceleration as lt raised to the power minus 2. Then distance s here, this distance s, distance is in length, so I will use L again. Now all over current is a fundamental quantity, so I leave it as I. Then t, time, is a fundamental quantity, so I leave it as t. Now what you'll be asking me is, how do I know fundamental quantity? Now there are about 7 main fundamental quantities. We have mass, length, time, current, and others. Now the best way to know them is, can you still break this down into simpler units? If you cannot, then it's a fundamental quantity, because fundamental means the basics, means the smallest. Do you understand? So time, what is the small, what can you divide time to? Can you divide time? No. If you have something like power, you know, work done over time taken. You can still break down power. So power is not a fundamental quantity. But now, coming to mass. Okay, what is mass? How can you break it down? You cannot. So mass is a fundamental quantity. Do you understand? All right, so now we move on. If we have something like this, coming to this place, I will have, now let me clean this because we will use this to get acceleration. So let me clean this. Now at this point, we'll be having, I'll write my mass back. Now we have one L here and we have another L here. And you know L is the same thing as L raised to power 1. And here is the same thing as raised to power 1. And the laws of indices, since the bases are the same, we just pick one. And since this is multiplication, what do we do to the powers? We add them. So 1 plus 1 will give me 2. Then we have our t raised to power minus 2 there, all over it. Now, if you check the option, it's not in this form, so we have to bring it to this format. I have t here, I have t here. Now, I'm taking it step by step. When you know how to do it, this thing you can do it in seconds, but I'm taking it step by step so you understand. So this is m l raised to power 2, then t raised to power. Now we have minus 2. You know this t here, same thing as t raised to power 1. So we have t here and we have t here. And the law of indices, since the bases are the same, I'll pick just one, right? And since this is division, what will I do to the power? I'll subtract the powers. So minus 2 minus 1. Minus because this is division. Now minus 2 minus 1 is what? Minus 3, right? So the power here will be minus 3, right? Then all over we still have I. Done. I can then bring it up to say electromotive force is equal to ml squared t raised to power minus 3. Then this I, if I want to bring it up, I'll just say I raised to power minus 1 because I'm bringing it up. So this is the dimension for electromotive force. Now, if you check the option, that's option A. So option A is the answer. So everything I did here was just to write out the formula and then we take it step by step. By the end of this video, we'll solve a lot of examples so you be used to it. So that's that. Let's move on to the second question. The second question says, which of these is a derived unit? Now, derived unit, derived means gotten from. That's what derived means. Now, derived units, which of these is a derived unit? Now, kilogram. Now, kilogram is a unit for kilogram, that's kg, is a unit for mass. And mass is a fundamental quantity. It's a fundamental quantity. So this is a fundamental unit. Meters, the second one there, meters. Meter is a unit of length. And length is a fundamental quantity. So this is a fundamental unit. Now Newton. You know, Newton is a unit for force. And you agree with me that force is mass times what? Acceleration. We've broken down force. Remember, fundamental quantities cannot be broken down. Since we've broken down force is not a fundamental quantity, but a derived quantity. So Newton here is a derived unit. The last one here, second is unit of time. You cannot break down time. Do you understand? So the answer to this question is Newton. Which of these is a derived unit? The answer is Newton. C is the correct answer there. Alright, moving on to the next question now. The next question says, the dimension of power is dash. Power. Alright, let's look at it now. Power. The formula for power, I told you, anytime you want to find the dimension, the first thing you have to do is to write the formula. If you don't know the formula, you cannot solve it. The formula for power is work done over time taken, right? If the formula for power is work done over time taken, then we can continue to say that work is already force times distance, right? Then all over time. Moving on, we can say force. We know force as mass times acceleration, then times our distance here, all over time. Remember, I'm using S to represent distance. We use S to represent distance in physics. Now, From here, we have it that mass, we use capital letter to represent mass, our fundamental quantity there. Acceleration, in the previous example, we found the dimension for acceleration as Lt raised to power minus 2. This is acceleration. Distance is L, then all over T. So I can now linearize it to be power will be equal to my capital letter M. Now we have 2L here, and this is same thing as raised to power 1, this is same thing as raised to power 1. And since you're multiplying them, you just take 1 according to the law of indices, then you add the power. So 1 plus 1 will give me 2. Then we still have T raised to power minus 2 here, and we have another T down here. Now this will be ml square. Now law of indices comes in again. We have T here, we have T here, but this is division. So what do? You take 1 and you subtract the power because of division there. So we'll be having T raised to power minus 2 minus 1, which is what? Minus 2 minus 1 is what? Minus 3. So we'll be having T raised to power minus 3. Now this is the dimension for power. ml squared T raised to power minus 3. That is option, where is it? Option A. Option A is the answer. All right. Hope you're following. If you have any question, please drop it in the comment section. Now let's move on to the third question here. The third question says, which of the following Alright, so the next question, which of the following quantities is fundamental? And there we're given area. Remember, I told you the easiest way to know fundamental quantity or derived quantities. Ask yourself, does this thing have a formula? If it has a formula, just forget it. It's a derived quantity. Do you understand? Can this thing be broken down? If it cannot be broken down, then it's fundamental. So now, they're asking which of the following quantities is fundamental? A, area. Now let's look at area first of all. Can you break down area? Yes, area, you know, area is length times breadth. So since it has a formula, you can break it down. This is not a fundamental quantity. Now, the second one, length. Can you break down length? What's the formula for length? Now you use your church mind and tell me the formula for length. Length is length. You cannot break down length. So length is a fundamental quantity. Speed, you can break down speed, distance over time. So it is not. Force, mass times acceleration, you can break it down. So it is not. So the only fundamental quantity we have here in this option is length. Hope you understand the concepts. All right, that's that. Let's move on to the next question. The next question says, which of these is a derived physical quantity? All right, now from what I've explained so far, what do you think is the answer here? Which of these is a derived physical quantity? Now, mass, is mass derived? No, mass is fundamental. Pressure, what is the formula for pressure? Pressure has formula. Pressure, you know the formula for pressure is force per unit area, right? So since it has a formula, you know this is a derived quantity. Length is not derived, time is not derived. So the answer to that question is pressure. All right, next question. Next question. The next question says, which quantity is derived? Now you can see how the questions are repeated. Which quantity is derived? Electric current. Can you break down electric current? No. So it's fundamental. Amount of substance is a fundamental quantity. That's mole. It's a fundamental quantity. Density. Density is a derived quantity because it has a formula, mass per unit volume. Now, temperature is fundamental. So the derived quantity here is density. Next question. The dimension of force is dash. I think we've solved it in course of the other example, but let's still solve it. The dimension for force. You know, force is equal to mass times acceleration. I told you the first thing is write the formula. Now, mass times acceleration. We've gotten acceleration before as Lt raised to power minus 2. Now, mass, I'll write all in capital letters. Remember, dimensions, you write them in capital letters. So our answer is mLT raised to power minus 2. That is option B. Option B is the right answer. All right, next question. All these things are WAEC and JAMB past questions, so take them serious. Next question, the dimension of pressure is dash. If you don't know the formula, you are gone. You cannot solve it. So the first thing is write out the formula. Pressure, what's the formula for pressure? Pressure is force exerted per unit area. That's pressure. Force, you are putting force per unit area. That's pressure. You are applying pressure. So if somebody say you're applying pressure, you're just adding force in that area. Okay, so that's pressure. Now, we just derived the unit of force now as mass mlt raised to the power minus 2. Then all over area. Area is length times breadth. Breadth is still length. So length times length. Length times length, which is mlt raised to the power minus 2 all over. Length times length is length square. Now, m, we have L here, we have L here. This is same thing as saying raised to power 1. L is the same thing as L raised to power 1. Now, I want to bring the two together. Since there's a division, the law of indices will require me to take one base and I will subtract the powers. So 1 minus 2 will give me what? Minus 1, right? 1 minus 2 is minus 1. So here will be minus 1. Then t raised to power minus 2. This is the dimension for pressure. This is the dimension for pressure. All right. Hope you understand. And if you're understanding, please, if you've not subscribed, click on the subscribe button and like this video. All right. Let's move on to the next one. And that reminds me, if you're not in my JAMB Online WhatsApp group already, my number will be showing on the screen. So you can just chat me up on WhatsApp and I'll add you to the JAMB Online group. It is free of charge. You're not paying anything. Only thing you have to pay is to subscribe to this video, and the subscription is free too. Nobody's charging you. All right, so let's move on. The next one, the dimension of work or energy is dash. Now, work and energy have the same dimension. Work and energy have the same dimension. And from what I've taught you so far, I told you the first thing you have to do is to do what? Write the formula. So work or energy, what's the formula for work? And what is the formula for energy? Work is same thing as force times what? Distance, right? Force times distance. And force is mass times acceleration. Then times our distance. And we've seen the formula, the mass is fundamental, so I write it out, times acceleration, we've seen it as LT raised to the power minus 2, and times distance is length. Now we'll be having mass times, this is L, we have one L here, we have another L here, and like I said before, the same thing as raised to the power 1, raised to the power 1. And since it's multiplication, what do? We add the powers, right? So 1 plus 1, 2, then t raised to the power minus 2. This is the dimension for work. That's option what? Option A. That's option A. All right, moving on to the next question. Which of the following set contains only fundamental quantities? Which of the following sets contains only fundamental quantities? A, mass, length, and time. B, velocity, length, mass. C, force, time, mass. D, area, length, current. First of all, you already know what fundamental quantities are from what I've explained. Mass, is it a fundamental quantity? Yes. Length, fundamental. Time, fundamental. So the answer there is obviously A. Moving on. Next question. Which of the following is a derived unit? Now, take notes here. Kilogram. What's kilogram? Unit of what? Mass. Mass is what? Fundamental. That one is out. M here. M here represents meters. Meter is unit of what? Length. Length is fundamental. That one is out. Newton. Newton is unit of force. Force is a derived quantity. So Newton is obviously a derived unit. A here is ampere. That's occurrence, which is fundamental. So the answer to this question is C. We've treated something similar before. Now the SI unit of power is dash. Now if you look at this thing, here J, joules, power, W, N. The answer is W, watt. So the SI unit of power is watt. Next question. Which of the following physical quantities has the dimension M, L raised to the power minus 3? This one, you have to look at it very well. They gave us the dimension and they are asking us the quantity that has the dimension. The dimension we're given is M, L raised to the power minus 3. This is a bonus question. You know why? M, you already know M is what? Mass, right? So mass. Then this L raised to the power minus 3. Minus 3 means there was a division line here. Then L is what? L raised to the power minus 3. If I put this division here, this division line, we have 3L here. That's length times length times length. And you know that this will be mass over length times length times length is volume. Volume is length times length times length. L cube. So mass over volume. Mass over volume is what? Now from the option force, density, energy, pressure, the answer is obviously density, mass per unit volume. Mass per unit volume. Alright, so that is that. Our answer there is B. Alright, moving on. I told you at the end of this one, there is no question you cannot solve on this. There is no question you cannot solve on this. Alright. The next one is the unit of momentum is dash. The unit of momentum is dash. Now, momentum, what's the formula? Momentum or impulse have the same formula. Now, mass times velocity. Mass times velocity. That's the formula. Mass times velocity. So momentum now will be equal to, mass is a fundamental quantity, so I use capital letter M, times velocity. Velocity is displacement all over time, right? Displacement over time. And you agree with me that this is same thing as saying mass times displacement here is distance, length. So I'll use capital letter L all over capital letter T for time. So this is same thing as saying M, L. If I want to bring the T up, T raised to the power minus 1. Remember, bringing it up, use minus 1. Good. But this is the dimension. We're asked for the unit. So from the dimension now I can get the units. What's the unit for kilogram? For mass, kilogram. That's the SI unit, not even grams, kilograms. What's the unit of length? Meters. What's the unit of time? Seconds. But we have minus 1 here. So where is that? That's option C. Option C is our answer. You see how simple it is. Alright, let's move on. The next question there says the SI unit of force is kilogram meter per second square. What is the dimension of force? In fact, this one they helped you. They already gave you the unit and asked you the dimension. So there's no need starting from the formula again. From the dimension, we're giving the unit as kilograms meter per second square. Now we're asked to get the dimension. Your own work now will be that at this point, you know, kilogram is the unit for what? Mass, right? You write your mass. Meter is the unit for what? Length. You write L. Seconds is the unit for what? Time. You write T. Raised to the power minus 2. I'm done. Now look at this. But the option you are seeing something 0 raised to the power this and that. Now, M is same thing as M raised to the power 1. L is same thing as L raised to the power 1, right? So our answer there is option B. Option B. M raised to the power 1, L raised to the power 1, T raised to the power minus 2. That's our answer there. Alright, we are getting close to the end. We're given another question here. We said, the question says, if the dimension of velocity is this, if the dimension of velocity is LT raised to the power 1 minus 1, and the dimension of acceleration is LT raised to the power minus 2, what is the dimension of force? This one, they just want to confuse you. They gave you dimension for velocity, they gave you dimension for acceleration. People like you should not be using it. What they are asking you at the end of the equation is dimension for force. We've solved that before. You know force is mass times acceleration. So at this point, mass is capital letter M because it's a fundamental quantity. Then acceleration, you're already given acceleration as LT raised to the power minus 2. That's all. That's all. And you know M is same thing as M raised to the power 1. L same thing as L raised to the power raised to the power 1. So our answer there is option A. That's it. So you can see that fundamental and derived quantity, the questions there will be very simple, but people fail this a lot because they overlook it, or how do I say it? All right. Now the next question here. If the unit of quantity Q is kilogram per meter per second square, find the dimension of Q. We're giving the unit as kilogram per meter per second square, and we're asked to find the dimension. To find the dimension, just from the unit, kilogram is mass, meters is length, so raised to the power -1. Seconds is time, raised to the power -2. That's our answer. Where is it? Option what? This is same thing as raised to the power 1. That's option A. Option A is our answer. All right. So moving on to the next. What's the next one there? Subscribe. So if you've not subscribed, please subscribe to my YouTube channel. We are going to, in the next video, we're going to be taking past WAEC and JAMB questions on gravitational field. So if you don't want to miss out, just click on the subscribe button, share this video to those that need it. I'm going to be demystifying physics. All the topics in physics, we're going to be doing this. So there's no way you go to JAMB or WAEC and you get stranded. There is no way. There's no way. All right. See you in the next video. My name is Excellent Simplified.